For conversion between decimal and scientific notation, the way I like to think about it is whether I have a large number or a small number. A large number is going to be any number greater than 10. A small number is going to be any number less than 1. So, 3.6 times 10 to the 8th. Well, 10 to the 8th, we've got a positive power, so that's going to be a 1 with 8 zeros behind it. That's a pretty large number. So if I've got 3.6 and I'm wanting this to be a large number, I'm going to move my decimal 8 places. In this case, to the right, making it a large number. So there I've moved my decimal 1, 2, 3, 4, 5, 6, 7, 8. And we use 3 places behind with a comma for place value. So thousands, millions, 360 million. Here, is this a large or a small number? Well, it's less than 1, it's very small. For scientific notation, I want 1 digit in front of the decimal that's non-zero. So this will be 3.24. Scientific notation is the only time you should be using a multiplication sign, and then times 10 to the. Well, was this a large or a small number? It's a small number, so my power on 10 is going to be a negative. I'm moving my decimal to here. 1, 2, 3, 4, 5, 6, 7, 8 places. 10 to the negative 8th. Now, in both cases, I moved my decimal to the right, but once it was positive, once it was negative. That depends on whether we're going from scientific to decimal or decimal to scientific. But if you think about whether the number is large or small, you'll always be okay. And here, 10 to the negative 8, we'd be dividing by a 1 with 8 zeros, so that's going to make this number very small. Here, I need in scientific notation 1 non-zero digit in front of the decimal, so this will be 6.7 times a power of 10. Now, is this a large or a small number? Well, large. It's definitely greater than 1. And I need my decimal to end up here, so I'm moving it 3, 6, 9, 10, 11 places. 10 to the 11th. Negative 2.503 times 10 to the negative 6. Large or small number? Well, I've got a negative power, so that's going to make my number small. I'm dividing by a 1 with 6 zeros. The fact that the number itself is negative, I simply disregard. I mean, I need to keep that the number itself is negative, but this has nothing to do with which direction I move my decimal. 10 to the negative 6, a small number, so I'm going to move my decimal 1, 2, 3, 4, 5, 6. Then I have my 2503. If you move your decimal and do these little loops, that is okay to see where your answer will be, but be sure you rewrite your answer without those loops, because if I've got something with a bunch of loops and 2 decimals, which decimal do I mean in my answer? This is not clear. Be sure you're always rewriting your answer clearly. 48. Well, I can only have 1 non-zero digit in front of the decimal, so this will be 4.8 times power of 10. Large or small number? Well, it's more than 1, so it's going to be a large number, and I'm going to move my decimal only 1 place. So times 10 to the first, or we might just say times 10. Now, this example is going to be useful in the next problem we do, because we will see arithmetic in scientific notation. The point of scientific notation is it lets us do arithmetic on really large or really small numbers without messing around with place value in any of the same way. Notice, all multiplication, times, times, times. So I'm not doing any distribution because this is simply multiplication. 6 times 10 to the 12th times 8 times 10 to the 15th. Well, 6 times 8 is 48. 10 to the 12th times 10 to the 15th. I've got the same base, so I can keep my base the same, and I'm multiplying, so I add my exponents. 12 plus 15, 27. So this is 48 times 10 to the 27th. But this number is not in scientific notation because 48 is not in scientific notation. But we've just done a little bit of review there. 48 in scientific notation is 4.8 times 10. So I can rewrite that 48 as 4.8 times 10 to the first. And then this 10 to the 27th is still tagging along. 4.8, I have the same base, 10. Add the exponents, 27 plus 1, 28. By converting that number into scientific notation, that's always going to help you move your decimal in the right direction, and it'll tell you whether this power should be increasing or decreasing. So simply rewrite the 48 in scientific notation, use your exponential rules, and then you'll be fine. And then I'm also going to show how you can do this on the calculator in another video.